Today we are going to see the subject power plant engineering, which is for third year mechanical engineering diploma students. This subject is for third year diploma mechanical engineering student. Now we are going to see the detail about it, but before that they have the 70 marks end semester exam. Progress assessment is having for 30 marks, and their practical end semester exam is for 25 mark, and the practicals progressive assessment is for 25 marks. Okay, now let us see further. Okay, this is what the Thomas Edison said, that I shall make electricity so cheap that only rich can afford to burn candles. Okay, after many experiments, first with carbon filaments and then with platinum and other metals, Edison returned to a carbon filament. The first successful test was on October 22, 1879. It lasted for 13.5 hours. Edison continued to improve this design, and on 4th November 1879, he has filed a patent having the number 223898, which was granted on 27th January 1880 for an electric lamp using a carbon filament or a strip coiled and connected to platina contact wires. This was the patent which was filed by the Thomas Edison. Okay, and this is also the first commercially practical incandescent light. Okay, so let us see the unit 1, that is introduction to power plant. Okay, so first, why electrical energy and why it is in the form of electricity. So this is how the electricity gets to your home. Okay, as you can see, at power plant the electricity is generated, then it's sent to the transformer station. In transformer station the voltage increases and it's sent to the tower for the transmission purpose. Okay, so whatever the electricity is there, it is transferred through a tower, through a transmission line, where to the transformer station, where this high voltage increased during first transformer station, it is reduced during the second transformer station. By reducing this voltage, it is carried out by the distribution lines, as you can see the poles near the roads or near your home, and then the electricity from transformer to pole, it enters into your home. Okay, this is how the energy we get in a house. Okay, so normally energy is measured in kilowatt hours and power is measured in a kilowatt. Okay, so there are two types we can say. Okay, so based on the consumption, energy consumption, that is, we can use this for commercial energy resources and non-commercial energy. Okay, these are the two resources where we can use the energy. Now let us see the introduction about this, the power plant. So electrical energy is most useful form of energy because it can be most conveniently transformed into other forms of energy like heat, mechanical energy, that we require in our day-to-day life. See, as we have seen the bulbs or tubes in our house, what happens, the electricity is converted into a light. Okay, and if you see further, in your home there is electrical coil is there. Okay, what it does, it converts the electrical energy into heat energy. Okay, so let us see further, but electricity is not readily available. Okay, it is required to be produced or generated in a factory called as a power station. Okay, like any other manufacturing process, the production or generation of electricity also need some cost to be incurred. plants and equipments, inputs, and the inputs may be in the form of water, fuel, etc. Ash smoke disposal systems, personal. Okay, and also it includes the cost of transmission and distribution to the large number of consumers of various categories, that is like domestic, commercial, industrial, agriculture, etc. Okay, so all these costs when added together, it constitutes the total cost of electricity, which in the consumers have to share according to the quantum of electricity consumed, taking into account the nature and time of use of electricity by each category of consumers. Now see here, as this subject is for diploma students, so I am going to teach in both languages, that is in English and in Marathi. Okay, तर आपल्याकडे जी इलेक्ट्रिसिटी येते ती फ्री ऑफ कॉस्ट नसते, आपल्याला काहीतरी त्याला पे करावं लागतं. का पे करावं लागतं, तर ती जनरेट करण्यासाठी किंवा प्रोड्यूस करण्यासाठी जे आपल्याला वेगवेगळे इक्विपमेंट वापरतो किंवा जे काही कन्झ्युम होतं, तर त्याच्यासाठी आपल्याला कॉस्ट पे करावी लागते. से फॉर एक्झाम्पल, जर तुमच्या घरात इलेक्ट्रिसिटी आहे तर ती काय फ्री आलेली नाही आहे की डायरेक्ट अशी घरातच जनरेट झालेली नाही आहे. ती कुठेतरी एका पॉवर स्टेशनमध्ये जनरेट झालेली आहे, तिथून ती ट्रान्सफॉर्मरला येते, तिथून ती टॉवरला येते डिस्ट्रीब्युशन लाईनला, त्या टॉवर थ्रू अगेन दुसऱ्या एका ट्रान्सफॉर्मरला येते, जिथे व्होल्टेज जी इन्क्रीज झालेली असते ती रिड्यूस केली जाते आणि त्या ट्रान्सफॉर्मरपासून थ्रू पोल तुमच्या घरात येते. तर पॉवर स्टेशनपासून ते तुमच्या घरात येईपर्यंत जो काही खर्च आहे तो खर्च ॲज तुम्हाला कस्टमर म्हणून पे करावं लागतं. ओके, so the question is that how this cost of electricity is to be determined in transparent manner. Some standard principles have been involved through ages of run and sale of electricity become more and more complicated. Methods of calculation of cost of generation of electricity in a thermal power station in terms of these basic principles, that is cost of electricity has two components, fixed cost and variable cost. ओके, तर इलेक्ट्रिसिटी जे आहेत ना त्याचे दोन प्रकार असतात त्याच्या किमतीचे. एक असते फिक्स्ड कॉस्ट, दुसरे असते व्हेरिएबल कॉस्ट. ओके, सपोज करा आपण एखाद्या मशीनचं एक्झाम्पल घेऊया. ओके, आता मशीन जी चालवतो आपण, से लेथ मशीन घेऊया आपण उदाहरण. लेथ मशीनचं जे आहे, जे इलेक्ट्रिसिटी बिल आहे, जेवढं तुम्ही रन करतात तेवढं तर ते इलेक्ट्रिसिटी बिल येतंच, ती झाली तुमची फिक्स्ड कॉस्ट. पण व्हेरिएबल कॉस्ट कसं की त्या मशीनसाठी जे आहे मेंटेनन्ससाठी जे लागतं, कॉटन्स म्हणा किंवा कुलंट म्हणा, हे जे आहे प्लस रिपेअरिंग कॉस्ट, हे जे आहे हे याला आपण व्हेरिएबल कॉस्ट म्हणू शकतो. ओके, so the basic difference between power and energy. Power, it is the capacity to generate or consume electricity. The term power specifies the capacity of generation or consumption in terms of kilowatt or megawatt. 1 megawatt, as we know, in 1000 kilowatt. Okay, energy, it is the power generated or consumed by utilizing the capacity of for a duration of time. It 1 kilowatt power has been generated if 1 kilowatt power has been generated or distributed continuously for 1 hour. It is said that an energy of 1 kilowatt hour has been generated or used. Similarly, if 5 kilowatt of power is generated or consumed for 2 hours, an energy of 10, which is equal to 5 into 10 raised to 2 kilowatt hour has been generated or consumed, and so on. Okay, this is what the difference between the power and energy. Now here you can see the different types of energy. Okay, renewable energy, non-renewable energy. तर तुम्ही जे आहेत इथं रिन्युएबल एनर्जी आणि नॉन रिन्युएबल एनर्जी हे दोन प्रकार आहेत. ओके, तर रिन्युएबल एनर्जी जी आहे ती कधीच संपत नाही आणि नॉन रिन्युएबल एनर्जी जी आहे ती कधी ना कधी संपणारी असते. ओके, सो रिन्युएबल एनर्जीमध्ये जे आहे त्यामध्ये येतं आपलं सन, विंड, हायड्रो, अशा वेगवेगळ्या प्रकारचे फॉर्म्स जे आहेत ते येतात रिन्युएबल एनर्जीमध्ये. आणि नॉन रिन्युएबल एनर्जीमध्ये जे आहेत कोल आलं, तुमचं नॅचरल गॅस, न्यूक्लिअर, हे जे आहेत हे नॉन रिन्युएबल एनर्जीमध्ये येतं. पण याच्यामध्ये जर तुम्ही बघितलात तर नॉन रिन्युएबल एनर्जी जी आहे ती कधी ना कधी संपणारी असते. ओके, त्या साठा किंवा स्टोरेज जे काय आहे ते कधी ना कधी संपणारे असते. तर ह्याच्यासाठी जे आहे नॉन रिन्युएबलसाठी अल्टरनेट जे आहे तर आपण रिन्युएबल एनर्जीवर फोकस केलं पाहिजे. ओके, उदाहरणार्थ जे आहे किंवा हे जे अवेलेबल रिसोर्सेस आहेत नॅचरली याचा वापर करून आपल्याला एनर्जी इलेक्ट्रिकल एनर्जी जनरेट केली पाहिजे. ओके, सो this is we are going to see the scenario. Okay, this is what the India energy consumption by fuel. Okay, जी नॉन रिन्युएबल एनर्जी आहे ती भारतामध्ये अशा प्रकारे कंझ्युम केली जाते. जर तुम्ही बघितलात तर हे जे आहे फ्युएल कन्झम्पशन आहे आणि हे वाय ॲक्सिसवर जे आहे फ्युएल कन्झम्पशन इट इज इन टर्म्स ऑफ टन्स, बिलियन मेट्रिक टन्स. ओके, आणि एक्स ॲक्सिसवर जे आहे ते इयर आहे. सी हावेवर द air is moving ahead, the graph is increasing in the form of, you can say, the exponentially, not a linearly, it looks like a exponentially. आणि तुम्ही जर याच्यामध्ये बघितलात तर सगळ्यात जास्त जे आहे फ्युएल म्हणून कशाचा उपयोग करतात तर तो आहे कोल. ओके, फर्स्ट जे आहे ते कोलचा उपयोग मॅक्झिमम करतात फॉर द प्रोड्युसिंग द एनर्जी. ओके, तर फ्युएल म्हणून जे आहे एनर्जी कन्झम्पशनसाठी जे आहे कोलचा जास्त उपयोग करतात. त्या खालोखाल जे आहे ऑइल आहे, त्या खालोखाल जे आहे ते नॅचरल गॅस, त्या खालोखाल जे आहे ते हायड्रो इलेक्ट्रिक पॉवर, आणि लास्ट जे आहे जे आहे रिन्युएबल जे आपले एनर्जी आहेत सोर्सेस त्याचा उपयोग करतात. आणि त्याच्या खाली जे आहे ते न्यूक्लिअर एनर्जीचा. तर तुम्ही जर बघाल तर रिन्युएबल एनर्जी जे आहे त्याचं जे आहे पर्सेंट म्हणजे बिलियन मेट्रिक टन्समध्ये जर तुम्ही ह्या ग्राफवरून बघितलात तर इट मे बी द अराउंड 0.001च्या अराउंड असेल. आणि तेच जर तुम्ही हे जे नॉन रिन्युएबल सोर्सेस बघितलात तर त्याचं कॉन्ट्रीब्युशन जास्त आहे. ओके, दिस इज व्हॉट द सिनारिओ ऑफ इंडिया इन एनर्जी कन्झम्पशन बाय द फ्युएल्स. ओके, नाउ further you can see over here, this is what the, let me show you. This is what the capacity of India energy consumption. This is the 3,30,000 megawatt India's energy consumption and its capacity which was in 2017. Okay, so if you see over here, okay, if you see over here, जर तुम्ही बघितला तर एनर्जी जी आहे कोल ॲज अ फ्युएल जास्त वापरून एनर्जी प्रोड्यूस केली जाते, विच इज अराउंड 58.3%. ओके, तर कोलचा वापर करून एवढी एनर्जी प्रोड्यूस केली जाते, दॅट इज 1,92,971.5 मेगावॅट electricity or power produced, electrical power was produced by using the coal. आणि त्याच्या खालोखाल जे आहे ते हायड्रो, लार्ज हायड्रो, स्मॉल हायड्रो हे दोन प्रकारचे आहेत. त्यांच्यामध्ये जे आहे 13.6%, 1.3% अशा प्रकारे इलेक्ट्रिसिटी प्रोड्यूस केली जाते. आणि जर तुम्ही बघाल तर विंड पॉवर, बाय युजिंग द विंड पॉवर दिस मच पॉवर इज इलेक्ट्रिकल पॉवर इज जनरेटेड. सेम for solar power, by using the solar, the electrical power is generated 4.5% of the total capacity, and by using the biomass 2.5%, by using nuclear 2%, by using gas 7.6%, by using diesel 0.3%. Okay, this much electrical power was produced by the fuel in 2017. Okay, even though you can observe this pie chart, the most contribution is by the coal, and then after that there is a renewable which is having 13%, but before that the hydro power is there okay, which is having 16%, then renewable 13%, and then here comes the gas 9%, nuclear 2%, and diesel 1%. It was in 2017. This is what the US energy consumption, okay. If you see, it's 36% energy was produced by the petroleum product, and then the energy is produced, or power is electrical energy is produced by the natural gas, which is having 27%, and the contribution of the renewable energy is a 10%, okay. So the first demonstration of an electric light in Kolkata, nowadays it is called as Kolkata, was conducted on 24th July 1879. Okay, India began utilizing grid management on a regional basis in the 1960s. India's capacity in 2017 it was 330 gigawatt. Maharashtra, Western India, with a total generation of 10,737 megawatt. Okay, see here in Maharashtra, okay, which was in Western India, in Maharashtra and Western India, it has having the power producing capacity was 10,737 megawatt. This much power was produced in 2017, okay, and in India's it was the second largest power producing company, okay. This is what the year wise India's electricity production. If you see in 1947, only the production capacity was 1362 megawatt. In 2016, its capacity, the production capacity was 3,26,840 megawatt, and in 2018, the electricity produced was that is 3,40,000 megawatt. Now, this is the graph of India's energy demand. That is, the graph is demand versus year. Okay, if you see the faint blue, it is the total power demand, and the dark blue is oil demand. If you see in 2000, the demand was 112. Okay, you will consider it as in the form of percentage, and the demand was 441. In 2013, if you see, the oil demand is 176 and total power demand was 775. If you observe here, the total power demand is increasing day by day or year by year, and same the oil demand is also increasing. If you see from 2000 to 2014, it is predicted that 308% increase will be there. Okay, as of December 2010, the installed power generation capacity of India stood at 169 gigawatt and is trying to add another 78 gigawatt by 2012, 330 gigawatt by 2016. The demand is expected to be about 1000 gigawatt by 2030. Okay, this is what the predicted demand. Now let us see the world's, that is the per capita energy consumption. Okay, these are the different countries' energy consumption per capita. It is also called as the indicator of growth also. Here there are different countries are given, that is UAE, Sweden, USA, Australia, Japan, Germany, China, Indonesia and India. Okay, if you see the per capita energy consumption, the Sweden is more, then later the USA, then Australia, then UAE, then Japan, then Germany, then China, and here it comes the India, which is having ninth, we can say at bottom position, which is having a 684. Okay, per capita energy consumption. Now, at the bottom here the source is there. Okay, now let us see the global energy consumption. That is the that is there is uneven pattern of energy consumption in different countries. As we have seen, there is uneven pattern, not a uniform pattern is there. Okay, uneven pattern is there in energy consumption. So if you see the developed country have population of 10% use approximately 90% of the available resources. On the other hand, there is country where people depend on wood as a form of energy. From last 20 years, developing country focus on energy sector. So the rate of growth in energy sector in developed country is 1 to 2%, but in developing country, the growth rate is 7 to 8%. Okay, this is what the energy developing by the energy producing by the developing countries. Okay, now let us see the energy scenario in India. By 2016 to 17, total domestic energy production of 670 million tons of oil equivalent. This meet only 71% of the expected demand. Okay, in 2016 to 17, total domestic energy production was 670 million tons of oil equivalent, and this only meets the 71% of expected demand. As per the 2011 census, 55.3% rural households had access to electricity. Still, most of the rural area have limited supply hours of electricity. That means जर तुम्ही बघितलात तर जी खेड्यात आहे तिथं पण इलेक्ट्रिसिटीचा लिमिटेड पॉवर सप्लाय होतो. जर आय थिंक तुम्ही लोड शेडिंग नाव ऐकलं असाल. ओके, दिस इज पार्ट ऑफ दिस द शॉर्टेज ऑफ द सप्लाय ऑफ द इलेक्ट्रिसिटी. ओके, now India ready to exploit renewable energy resources. India has electrified 96% villages but is still far from taking power to all homes. Okay, now India has one national grid with an installed capacity of 330.86 gigawatt as on 30 November 2017. Okay, this is information which is from Wikipedia. Now let us see the share of fossil energy is 66.2%. Share of renewable energy was 31.8%. GHG emissions from electricity generation 2015 it was 2066.01. Okay, now average electricity use in 2016 and 17 was 1122 kilowatt hour per capita transmission and distribution losses. Okay, and the distribution losses was 21.81. And further, percentage residential consumption was 24.32%, industrial consumption was 40.01%, agricultural consumption was 18.33%, commercial consumption was 9.22%. Okay, services share of private sector in generation is 44% on October 17. Now let us focus on the Maharashtra. आता महाराष्ट्रावर. ओके, तर लेट अस सी द थर्मल पॉवर प्लांट ऑपरेशनल. तर आपण बघूया की औष्णिक विद्युत केंद्राची कॅपॅसिटी किती आहे. ओके, इफ यू सी द चंद्रपूर thermal power station, its capacity is 3340 megawatt. Koradi thermal power plant station 620 megawatt. Khaparkheda thermal power station 1340 megawatt. Bhusawal thermal power station 1420 megawatt. Nashik thermal power plant station 630 megawatt. Parri thermal power station having capacity is 1130 30 megawatt. Paras thermal power station is capacity is 500 megawatt. See the power plant operational. Okay. So this is what the power plant's capacity is there. If you see the Chandrapur thermal power plant's capacity is more than the other power station, and the Paras thermal power plant's capacity is less compared to others. Okay. Now let us see further. These are the hydropower stations. Okay, Bhadgar Dam, Bhatsa, Bhira, Dimbe, Ghadgar, Kanner, Koina, Manikdo, Panshet Dam, Pauna Dam, Surya Dam, Tilri Dam, Uzni Dam, Vaitarana Dam, Varasgaon Dam, Veer Dam, Varna Dam, Vedal Dam. These are the dams, and out of these, on few dams, the power station is established. That is, you can see on Bhira is having 80 megawatt, Ghatkar pump station having 250 megawatt, Koina hydroelectric power plant 1956 megawatt.